Okay, so we're starting with 12.5. We've been on 12.4, you added rational numbers and subtracted rational numbers, so you got the hang of it there. But now we're going to add the same with fractions of any sorts. Once we do fractions that are rational expressions that have fractions in them that have different denominators, it makes it a little more difficult. If you think back at just when we talked about adding and subtracting, just plain fractions in general, you'll remember like it's pretty easy to add 1/4 plus 2/4. You just add the top two and the bottom stays the same. But when you have numbers of fractions where the bottom numbers, the denominator is different, you have to find what we, if you recall, the LCM. The LCM of 8 and 24, to find the LCM, you have to factor these two numbers to find the LCM. Now, this you probably know already without factoring. You know that 24 is going to be the LCM, the lowest common multiple, because 8 is a multiple of 24. You know that. But I want you to go through these steps with these fractions, so that you can remember the steps, because you can't do this in your head for the rational expressions that we're going to do today. So these are the steps. You factor this out. We do a factor tree with these. So you would do 4 times 2, 2 times 2. So 2 cubed would be 8. With 24, we could do 6 times 4, 2 times 2, 2 times 3. So for 24, prime factorization would be 1, 2, 3. So 2 cubed times that 3. Now, if you remember way back to when we did LCMs, the LCM, after you get the prime factorization, you take the product means multiply, right? So the product of the highest power of each factor. So if we look at these two prime factorizations and we look at the 2's, the higher one is, well, they're both 2's cubed, so that's the highest one. So 2 cubed, product means we're going to multiply the next one, and the highest one of 3. This one doesn't have any, so through this 3 would be the highest. Okay, so this is going to be our LCM. And 2 cubed is 8 times that 3 yet, which is going to equal 24. So our LCM is indeed 24. Okay, then the next step we did was we looked at these and we said, okay, let's change these both to 24. Well, this one's already changed, so we can just write that one right over here. We already have 24. But how do we get this 1/8 changed to a denominator of 24? Well, remember we talked about how, okay, what times 8 would make 24? Well, 3 times 8 would make 24. So we need another 3 here, but we can't just multiply this by 3. We can multiply it by 1, though, because 1 does not change an answer. So you have to have 3 over 3, which is equal to 1, and multiply that by the denominator that isn't the right LCM. So now let's work through this. So then we multiply across. Now we, voila, have that 24, but it makes the top change to 3, and we have another 3 24ths. So the answer is 6 24ths. Okay, which we can then reduce to. But this right here, finding the LCM, and then changing it so that it has the matching denominator, is the key to what I want you to remember and recall from when we did fractions until now, so that we can do this next step. Adding in rational expressions with different denominators. All right, don't let this intimidate you. We'll walk through it and it'll become clear. So we have these two denominators. They're these irrational expressions. And you're looking at it going, how in the world am I going to figure out what is common between them? Well, we've learned how to factor rational expressions, right? So we need this LCM, but first we have to factor, just like we did up here. when we did the fraction, right? We need to find the LCM. We just factor this, and then use the product of the highest power of each of those. That's exactly what we're going to do here. Okay? So we've been teaching you the last couple weeks how to factor this kind of stuff. First step is always to look for common, remember, common factors. Well, I see common right away. These all have x. In fact, this one has 2x, this one does, and this one does. So let's factor out 2x. From this, would leave that. From that, would leave that. From this, would leave that. So now we've found two factors, right? This is a factor, and this is. But now you should look at this, and you should right away think, can I factor this? Because now, look, I can maybe find two binomials. Remember, this does not drop. It still is there. That's still a factor. Are there two binomials that when we multiply, it equals -10, but when we add, it equals -3? Let's see. 2 times 5 is 10. 2, so -5, or -2 times 5. Look at that. You should see that there's a difference of -3 right here. Let's try that. So x minus 5 and x plus 2. 2x, -3x, -5x, sorry, would be -3x. So we found two more factors, okay? So we have three factors for this rational expression. All right, now we cannot factor these anymore. So let's try the next denominator. Next denominator is here. First, look for common threads here, common factors. And indeed, you do have a common factor. What do you have? No x's, because there's none here, but we do have a 3 that's going to factor out of here. Out of here, we'll leave this. And out of there, we'll leave that. Now, right away, you should think, okay, am I going to be able to factor this out too? Don't drop that 3. It's still part of the factor tree of that. I right away see this and I think, oh, I know this is a perfect square. And this is a perfect square. If I use this perfect square of 5 times 5, could it equal a -10? Yes, indeed. Because if I use -5 times -5, that still is a positive 25. So if I do -5 and -5, -5, -5, indeed it's a -10x. And this is a positive 25. So you found the factor tree for that denominator. Now, let's go back to what we talked about before. What is the LCM? We found the factors, but now what is the LCM? The LCM is the product, okay, we multiply these things together, of the highest power of each factor. Okay, highest power of each factor. So here's our prime, kind of our prime factor tree of this expression. And here's our final prime factor tree of this expression. So you just go down the line. You say, okay, is 3 the highest one? Yeah, there's only a 3 there, so we take the 3. All right, what about x minus 5? Well, there's 2 x minus 5s here. There's 1 there. So which one do we take? We take the highest. So x minus 5 squared. Okay, so that takes care of all this one, but what else is left here? Well, we don't have any x squared yet, do we? So we need to add that. I'll put that out front. And then we don't have any x plus 2s. There were none down here, but we still take the highest of that one. And now we have found our LCM. Okay, so let's rewrite and reorganize that a little neater. This, all I would do is switch this around. So it would be, let's do it here so we can bring these down. 3x squared, x minus 5 squared, x plus 2 is our LCM. So not too bad, right? It's basically the same ideas, just trying to find what that least common multiple is. Okay. All right, let's try something else. This time, let's do this all the way to the end. Here's a little simpler denominators. They're not common, so we cannot add the top, right? So how do we make these common? We find the LCM. First thing we do is we take that 2a and we factor it out. Well, a factor tree of 2 is just 2, right? 2 times 1. So we just have a 2. Factor tree of a is just a. So really simple, right? Factor tree of 8 would be 2 cubed, and then times just that a. So LCM, again, is the product of the highest power of each factor. So we have factors of 2 here. We take the highest power. So that would be 2 cubed. We have a's here. Highest power, they're both just a. So our LCM would equal 2 cubed a, or 8a, which makes sense, doesn't it? All right. So now how do we get, we have this one is already 8a. How do we get this denominator as 8a? Well, you just kind of think, I have 2a. How can I make it 4a? Well, the a is already there. What can I do to 2 to make it an 8? Well, I can just multiply it down times 4, right? So if I multiply this times 4, it's going to be 8a. But you cannot do it to the bottom unless you do it to the top. Because now really you're multiplying by 1, which anything multiplied by 1 is itself. You're just manipulating how this looks. So we can add it to this. And then of course this stays the same because it already is 8a. And then here, let's just simplify now. This would be 12. This would be 8a plus 5 over 8a. Now that the denominators are the same, we can add the tops. So we add 12 plus 5, which is 17 over 8a, which is our answer. Okay, watch it again if it's too fast. I don't have your feedback because you're not standing right in front of me. But basically, it's the same thing over and over again. Find the LCM, and then you have to, find out how you're going to make each denominator that LCM. Okay, let's try another one. All right, this time we have 3 of them. Okay, we need to find the LCM of these 3. First thing you do is factor. To find the LCM, we factor out, make that kind of that factor, prime factor tree. This one's easy again. It's a prime number. And then x is just x. Same with this guy. Okay? 12 we can factor out. 4 times 3, 2 times 2. So we have 2 to the second power times 3 times x squared. So what's our LCM? We take the product of the highest power of each factor. Okay, so we have, let's start with our 2's because they're the lowest. The highest 2 is 2 squared. 3, highest one is 3. And then x's. Highest one is x squared. So our LCM would be 4 times 3x squared, or 12x squared. Perfect. Now we know what our denominator is going to be. It's going to be 12x squared. So let's try to make each of these 12x squared. This one conveniently already is. But now I have to know how to manipulate these two so that they have a denominator of 12x squared. Let's think it through. Let's rewrite this guy. Now, 12x squared. How am I going to make 3x 12x squared? Well, to get the 12, I'm going to multiply by 4. To get the x squared, I just need one more x, right? So I'm going to multiply by x. But I can't just do it to bottom. I have to make it times 1 because that doesn't change anything. So I make my 4x over 4x. Okay, next one. 2x. How do I get that to be 12x squared? Well, 6 times 2 would be 12. And then again, just another x will make it x squared. And again, I have to make it 1 so I don't change anything. And then this last guy has the denominator we want already. It's long and tedious. You need to be neat and write large so you can see everything clearly. Okay, order of operations says that we got to multiply first. So let's do that before you add anything. Get all these multiplication things out. So this is where it might be a little tricky for you. This is easy to multiply, right? Because we know what we want, 12x squared. However, that top, this is a number and this is a number. So what do you need to do? Distribute, right? So 4x times 2x becomes 8x squared. Don't forget there's two x's. And then 4x times minus 5 would be minus, right, 20x. Okay, now we have this one. Same idea. This is one number, this is one number. We need to distribute. 6x times x, 6x squared. 6x times minus 1, minus 6x. And this should be, you can double check it, but it should be 12x squared. And this guy, he's already okay. Okay, same denominators. That's what we want. Okay, so now comes the cool part. When you have the same denominators, all this up here can be added together. Okay, we can just write it all over this denominator. So really what you need to do is just look at the like terms and add them. So we have 8x plus 8x squared, excuse me, plus a 6x squared be 14x squared. Then we have a negative 20x, a negative 6x, and a 5x. So this would be negative x, and this would be negative 20, so we got a negative 21x. Okay, then, so we got these done. We got that one done. We have this guy here yet. We just have a lonely 6 by himself all over 12x squared. That's it. That's, oops, excuse me, that's your answer. That is simplified, and that takes these three, adds them together to be 1 here on the bottom. So I think you will be able to do this lesson without a problem. If you would like to, when you get to number 16, I'm going to do 16 here with you. So you can turn it back on when you get to this and kind of have a little refresher review at the end of this with 16. So this is how you're going to work through 16. Same idea as the one we just did. Two different rational equations or expressions. And you're going to find the LCM. In order to do that, we need to factor. Find what the factor tree is. Basically, the factor tree for these expressions. Is there something we can factor out that's common? I don't think so. Looks like we can't do that. So then we have to look for, when we multiply, it has to equal a negative 27. When we add, it has to equal negative 6. So think about that for a moment. I know negative 27, I want to get in the negative 27 would be 9 times 3. And right away I think, the difference of that is 6. I need a negative, so if the bigger one is negative, smaller one is positive, let's try it. X minus 9, x plus 3. Be negative 9x, positive 3x, which is a negative 6x. We got it. So there's our factor tree. So we do the same thing to this one. Anything common we can factor out. Doesn't look like it. No x's and everything. And we have a 3 that's common here, but not here. So if I multiply, it needs to be a negative 18. When I add, it needs to be a negative 3. So think about your 18 to be negative. Well, 9 times 2, that'd be a 7 difference. It probably isn't that. What else could we do? 6 times 3. Ooh, that would be a difference there, right? So if I do a negative 6, positive 3, that would be a negative 3. So let's try that. Negative 6, positive 3 would be negative 3. 6 times 3 is negative 18. Excellent. Okay, we have our factors. Now we need our denominator. So we use our LCM, which is going to be our denominator. So our LCM will be the product of the highest power of each of these factors. Okay? So we have an x minus 9 here. It's not squared or anything, it's just x minus 9. We don't have any here, so that's the highest one. Okay, and then we have an x minus 3 here and 1 here. So the highest would be 1 because they both have the 1. And then an x minus 6 here. It isn't up there, but it is here, so we need to keep it in. And that would be our LCM. We've done them all. Now you're saying, how do we get this to look like that? So what I'd first do is look at it this way. This guy here is this, right? Or this. You can write it either way. These are equal to each other. So we're going to rewrite this guy as 10 over x minus 9, x plus 3. And we'll rewrite this guy to what we factored it out to be. Because it's the same thing, we're just using the factors. Then we can see them a little more clearly. Whoops. Okay. Now let's give them our new denominator, this LCM. Okay? If we have 10 over x minus 9, x plus 3, what do we need here in order to make this? Oh, we have this. We have this. We just need to multiply this, right? So if we multiply this on the bottom, we'll have this. But just like before, we can't just multiply here. We have to multiply by 1. So if we do it on top, then it just makes it 1, and this will become an LCM denominator of this. Just like that. Simple. Now we add this to it and change it to the right denominator as well. So let's write it here. Okay, so we have x minus 6, x plus 3. What are we missing? We're missing this guy, right? So if we just add him down here to multiply him by that, but we have to make it a 1 so it doesn't change anything. All right. Should be coming a little more clear to you. So now these denominators are the same. They're in a different order, but remember multiplication, the order of multiplication doesn't matter, right? I could slip this in the front here and it would still be it's the same denominator. So now I'm going to write the bottom as the same denominator, right? Because they're the same denominator, let's just write it once. Then we can just write this. This is times this, right? Okay, we're multiplying this and this. So this times this plus this times this. Don't forget the parentheses because you're going to have to do what? Okay. All right, I'm going to have to skip down over my LCM here. Now we distribute. So 10 times x would be 10x. 10 times negative 6 would be negative 60. Plus 8 times x would be 8x. 8 times negative 9 would be negative 72. All over that same denominator. And now, what do you think we do next? We're going to look for those common threads. Okay, I see here and here would be 18x. And I see here and here would be 132, I think. I think that's right. And then the denominator, when you add, remember, as long as it's a common one, it always stays the same. Nothing changes there. That is your answer. All right, you can do this. Hopefully you did a bunch of work before you watched this one, and hopefully you were able to do a little bit of this one before you watched it. So have a good day, and we'll see you tomorrow.